So after we apply the loads, we're now on part of the analysis, all right? But before proceeding to analysis, we have to verify our mesh. How do we do the mesh? Just click this icon over here. Okay. But I'd like you to hide loads here so that it won't be complicated when you show the results. Go to display, and then from here, go to loads and uncheck this load symbols over here. We'll remove the applied symbol for loads. All right, and also the dimension, you can actually select them and delete one by one if you don't want them in your model, right? Okay, always choose self-weight so that when you show the results, it won't give you a lot of things on the screen, which is quite complicated. All right, so before we go for analysis, let's check our mesh. Hit this icon over here, and it will show you these options for FE mesh generations. Always choose these meshing options, and no panels selected for this operation. It's fine. You can say yes, it will be applied to all, and here we are. But there's a thing that I need to do, since I think I pretty much ran the analysis once, or ran the model once, so that's why nodes has been generated here. So there's mesh on this area, but just for the sake of presentation, I want to show you again how to do the mesh. So for this case, if I want to delete mesh on my existing, or delete existing mesh, I'll just go to this options of FE mesh generations and click this icon over here, which is local mesh deleting. It will delete the existing mesh. As you can see, nodes has already been deleted. No worries, loads are still there. That's the good thing about the robot. You can delete nodes, but you're not actually deleting elements. Right. Okay, hit this icon over here, which is meshing options, and it will give you a warning. Do you want to apply it on the entire structure? Yes, if you're applying on the entire structure, since we are just dealing with shell elements for this type of structure. All right. And for the meshing options, I suggest that you use this option here, which is complex mesh generation delineate, and your mesh size. I prefer a mesh size of 0.5, to be honest, because this gives you a very, realistic results, I would say, for this type of structure. But still, you have the flexibility to play around on your mesh size. After you put it in here, make sure to go for the advanced options, and this will give you, like more options to actually refine your mesh distributions. So here I've got a size of 0.5. Usually this is thick by default, but you have to uncheck it, because it will give you better mesh arrangements. Okay, check delineate here, and then that's pretty much all what I suggest you to apply. And then okay, and then after that, whether you hit this icon over here or not, when you run the analysis, it will automatically create the mesh. But for this presentation, I will hit generation of calculation models, just for you to be able to see what's going to happen. Okay, now it's creating mesh on your model. You won't see it because the display button for mesh has been turned off. You go to panels FE and finite elements, and click this finite elements over here. All right, so that's it. That is how the mesh looks like. For me, this is a nice mesh for this particular type of structure, radial, right? Okay, so that's how actually we create mesh. After that, we are now ready to run the analysis part. Hit this icon over here. This is how you run the analysis. Okay, it will give you some warning, no supports, because the main reason is because we've applied the supports directly on the element itself. So this no supports warning here is acceptable and it's normal. Usually does happen. But if you're going to apply supports on each node of the base, which is quite complicated, I don't want to do it, and it's not practical. You just have to apply the KZ, KX, and KY values, or the soil or subgrade modulus, exactly on your base slab, and that's actually pretty much easier. All right, so now that we are done with the analysis, there are things that we need to check. For me, what I have to check first is my uplift. On my uplift, I will have to check if the buoyancy force is lesser than the gravity loads coming from the weight of the structure and on the soil surrounding it, because that's very, very important and very critical to check. It will actually dictate also the size of your elements, right? So what I have to do is I'll go here on result, okay, and go to reactions. Sorry. So on this one, it will give you a summary of loads, Fx, Fy, and Fz. We will be focusing on the vertical reactions. So as you see here on self-weight, it will give you this summary of reaction, 2432.49 downward. Remember that for a positive sign, it's upward, and then this one is downward. So basically, this is the summary of force downward, negative 2432. So we will be expecting in an uplift that this should be negative, okay? I'll just showing this one for you just to be able to know the difference between the summary of reaction sign, positive and negative. Negative means downward. Let's go to uplift. Remember that in our uplift combinations, we've already summed it all up, the vertical actions. So from the dead weight to the uplift due to the hydrostatic force. So as you can see here, it's positive, which means that it's actually going up. So we have some small problems when it comes to uplift to 170 kilonewton. Not a huge one, but we need to work it out. So there are things that needs to be done to be able to correct the uplift pressure. It means that the hydrostatic force is bigger by 170.35 kilonewton, making your structure unstable. Right? So how to correct it? There are several ways. Either one solution is we have here a 0.35 thick of reinforced concrete. Usually what they do on site is they put the mass of concrete on top of this 0.35 reinforced concrete. Let's say we will reach up until a level of 1 meter, which is exactly the ground level. We will put a mass of concrete of around 1 thick and the same width as this one. So that means that we're going to apply loads, and we'll just assume it as a furniture. And then we'll go to surface and hit this icon over here, and we'll be applying a mass of concrete. What's the mass of concrete? Normally, let's just assume 24 kilonewton per cubic meter multiplied by 1 meter. So that's around negative 24. And apply on this perimeter, this area. Furniture. Okay, it's already been applied there, but you can't see it. Maybe apply. All right, apply. There you have it. That's negative 24 kilonewton per cubic meter there. And then we run again the analysis, and let's see if the uplift is corrected. We go on the same results and then reactions. And then let's go over on the uplift combinations. So here, the summary of force is now negative, which means let's go back again here on the weight, which is always how we assess the signs. Basically, the summary of force is negative, and it's downward. So it means this is the weight of the structure. It's going downward. Then we go to uplift. It's negative 816.86, which pretty much okay for now. All right, so it's already been solved. Uplift is okay. What's next? We need to check basically the soil pressure. The soil pressure should not be more than the allowed soil bearing capacity that's written on your soil report. Let's say, I think if I can recall, we've specified a maximum soil bearing capacity of 75 kilopascal. So how do we show it? Let's go to results, and then maps. Click this icon over here. And then from here, you can see soil reaction scale. Very important, you need to choose these directions. What's the directions of showing the values? So if you click this one over here, it will give you this. It goes to my other lesson. It should be polar because we're dealing a circular base. So we're choosing a node 0, 0, 0. That's basically the center of the base, and click OK. And then just choose soil reactions over here and then apply. But don't forget to check FE mesh with description, or just unclick description for the meantime. It will show on this area. So you see here that the maximum pressure is, of course, it's very small because we're choosing the wrong load combinations. So we've got a lot of load combinations in here. So it's very important to know what are the load combinations to show. For this one, soil pressure. So we will be checking for the ULS combinations. And ULS combinations start from number 8 going on to 12. Okay, take note, 8 to 12. Hit this icon over here, which basically how to select the cases that you are going to show. And just delete this number 2 over here. We are going to choose 8 to 12, but hit this combination here, combination. So from 8, 9, 10, 11, 12, and then go up. That's it. That's basically how to choose. Or just simply write 8 to 12. It will show you the pressure on the base. Okay. And results, maps, sometimes it shows the wrong elements. But what you can do is with FE meshed, there you have it. So the pressure at the base, as you can see, is red, and it signifies 62.45. It's almost there. We've almost reached the maximum soil pressure, but it's lesser than 75 kilopascal. So I can say we are safe. We are safe for the soil pressure. Next is we are going to check for the displacements. Remember that we've set a maximum of 25 to 50 mil basically for water retaining structure, but this is a type of, let's say, water containing structure because it's a preliminary settlement tank, so it contains sludge and water. According to Eurocode, it's around 25 mil to 50 mil maximum. That's the total displacement. All right, not the differential settlement. I believe that differential settlement here is not that critical, but we also can check it. So same options, results, maps, and then don't forget to uncheck this once, right? And go to displacement, but check Z over here and apply. Now, the maximum displacement is -9, which is quite very low and very acceptable. And also I'm showing a ULS load combinations over here. And actually for displacement, we're supposed to be using the SLS combinations. So to select it, you just go over here again, or just go to combinations and select from 14 to 17. You can delete this one here from 14 going to 17. 14, control 17, and click OK. Okay, so that's how you select load combinations. And now it's showing -5, pretty much okay. Very good results for displacement. How about differential settlement? You can see from the contour that on the center, it's -1. On the last part, it's somewhere like maybe basically at the base of the wall, it's -5. So differential settlement is not a problem at all. Okay, so that's how to preliminary check your model. Otherwise, if you have some problem on your uplift and you already put a mass of concrete at the perimeter and still the problem still exists, all you can do is you have to, I wouldn't suggest this because it's quite uneconomical to thicken your elements. Basically, if you thicken your elements, it will increase the dead weight, and that will counterpart or counteract the buoyancy force that's acting on the lower part or the base of your structure. Okay, next up, we are going to provide reinforcement for this one. So basically, we'll be checking the maximum MXX, MOY for the base and for the walls. And that will be the last part of this presentation.